You'll have to forgive my sketching skills a little bit here, but I've drawn two groups of figures. So at the top we have prisms and a cylinder, and we've looked at the formula for finding the area of these in 3.1. It was the area of the base times the height. And when we talk about the base, we're talking about this shape that appears on two sides of this figure. And the name of the figure is defined by what that shape is. So we have square prisms, we have rectangular prisms, we have triangular prisms, we have cylinders, and they're all defined by having the same shape on two opposite sides. So the triangular prism has two triangles on opposite sides. The cylinder has two circles on opposite sides. The square prism or the rectangular prism has two squares or rectangles on opposite sides. And in all of these cases, this area of the base ends up being whatever area formula is required to find the area of that side. So for the cylinder, it would be pi r squared, since we're dealing with a circle. For a triangle, it would be base times height divided by 2, since that's the formula for a triangle, and length times width for the rectangle, and that could even be used for the square. We could also use side squared. Now, pyramids and the cone. So there are similarities between these two shapes, but the key difference is that instead of a shape being repeated on two sides of this figure, the shape is on one side, and then the other side comes to a point. So you can see for the cone and for the pyramids, instead of having the shape on both sides, we have the shape on one side and we have a point on the other. Now the volume formula is very similar. Area of the base times the height of the figure, but then we take that result and divide it by 3 if it is a pyramid or a cone. And when we're referring to the area of the base, we are once again referring to the shape that appears on one side of this pyramid or cone that is opposite of the point. So it would be pi r squared would be the area of the base for the cone. For the triangular pyramid, it would be base times height divided by 2, the height of the triangle. So that height right there, not the height of the actual pyramid itself. And length times width, or side squared if it's a square, for the base of the rectangular pyramid. With that in mind, let's take a look at some examples of using this formula to find the volume of a pyramid or the volume of a cone. Question number 1. A cone has a diameter of 10 centimeters and a height of 4 centimeters. What is its volume? So I typically like to start by just doing a sketch of the figure that we're trying to find the volume of if it's not provided. So in this case, we have a diameter, which is 10 centimeters long, and we have the height of our figure, which is 4 centimeters. Unfortunately, you can see I didn't draw this to a very good scale. That being said, we can just use this as a guideline to help with our volume formula. We are dealing with a cone. So it's going to be area of the base times the height of the cone divided by 3. So for the volume of this cone, the area of the base is pi r squared. We're going to multiply the area of that base by the height of the cone, and then divide that by 3. So let's see. What is the radius? Well, we know that the diameter of the cone is 10 centimeters, so the radius is going to be half of whatever that diameter is. So therefore the radius is going to be 5 times the height of the figure. So that is this height of the cone itself. So that would be 4 centimeters long. And divided by 3. Oh, forgot to square my radius here. So the volume of the cone we can just take that entire formula as we see it and put it into our calculator, and I ended up with 104.72 centimeters, and notice that this is a volume, so this is going to be centimeters cubed. Second problem. So we have a square pyramid, and the square pyramid has a height equal to 20 millimeters. So that's the height of the pyramid is 20 millimeters. The square base has lengths of 8 millimeters. So that means this side length is 8 millimeters. It also means that this side length over here is 8 millimeters. In fact, all of those side lengths along the square would be 8 millimeters long. What is the volume of the square pyramid? Well, we're dealing with a pyramid, so therefore we know that we're going to use the volume of a pyramid formula, which is the area of the base times the height divided by 3. Our base in this case is a square, so we can use side squared or we can use length times width. It ends up being the same thing. I'll use side squared times height divided by 3. If this was a rectangle, you would have to use length times width for the area of the base. We don't have to because it's a square, but either one would work here. So the volume of the pyramid is equal to side squared. Well, our side length is 8, so that's 8 squared, times the height of the pyramid, and we're given in the problem that the height of the pyramid is 20 millimeters, and then we're going to take that entire answer and divide it by 3. And that gives us 426.67 millimeters cubed for volume. So you can see that the real difference in finding the volume of a pyramid versus the volume of a prism is just that we're going to have this division by 3 when we finish calculating our numerator. So that's an overview of finding the volume of a pyramid or the volume of a cone.